Okay, so one other story, just quickly, is another water story on Mars. So back in 2001, the Mars Odyssey spacecraft entered Mars orbit. And one of the instruments on board Odyssey was a gamma-ray neutron spectrometer on the end of this long boom. And that allows, from 100 kilometers away, to measure gamma rays that are being bounced off of the surface of Mars. And these come in as cosmic rays, and they reflect as gamma rays and also knock neutrons off of the various rocks that they're looking at. And the one thing that this is really good at is detecting hydrogen, because the neutrons in particular are a good indication of how much hydrogen is in the target. And for Mars, the hydrogen is related to water, H2O. And so back in, I think it was 2002 or thereabouts, they released this global map from the gamma ray spectrometer, and all the blue stuff is where they detected a fair amount of hydrogen. And the analysis of this was that in these areas, the top couple of meters of the surface is probably a couple of tens of % water mixed in with the regolith and in the form of permafrost. And that was surprising, because prior to that we expected that would only be in the polar regions, say 75 or 70 degrees latitude or higher, but they actually saw things down as low as about 40 degrees in some areas. And so back in 2008, we sent a lander up near the Arctic Circle of Mars, about 76 degrees latitude, I believe. And it had a robotic arm on it. It was designed to reach out about 6 feet or so and act like a little backhoe and then scrape the surface away. And so here's where they landed. And this is a view of one of the trenches that they dug. This white stuff is water ice. And that was only about 10 centimeters below the surface. And so that was a good validation of the gamma ray spectrometer results, that yes, there is permafrost on Mars. But still, the assumption was that mostly this is at the higher latitudes. And then this most recent result is from the Mars Reconnaissance Orbiter. It's a high-resolution camera and an infrared spectrometer on board. And they took some images across sort of a collapsed area. This is a couple hundred meters deep, so this is a couple hundred meters lower than the surrounding flat plains. And then there's spectrometer results right across that path, as well as a higher resolution color view from this camera. And all this blue stuff is water ice. And it turns out that's only about 5 to 10 meters below the surface, but this is about 100 meters thick. And that's a lot of water. And this is at about 50 degrees latitude. So that's certainly not what you would consider the Arctic. And it's a really interesting result, because if you can find areas like this, and, well, I should say if and when we send people to Mars, being able to have access to something like this where you could drill down, excavate water, turn it into drinking water, hydrogen and oxygen for rocket fuel, that would make these missions much, much easier rather than shipping all of that from the Earth. So this is a really exciting result that was just released in December. And they've found, I think this is the 6th area that they've found evidence like this. And so now we're going back and looking in lots of other areas to see how widespread this is. Okay, so a quick look forward. The next mission to Mars looks a whole lot like the Phoenix mission, but it's actually designed to look at the interior of Mars. It's got a very sensitive seismometer and a heat flow instrument. So this instrument, it will drill about 15 feet or so below the surface. It'll insert a temperature probe, and they'll be able to tell how much heat is escaping from the interior of Mars, which tells you a lot about the internal structure. And then the seismometer can look for Mars quakes. It could detect impacts of meteoroids, and even if there's large gusts of wind, detect that. And so this spacecraft was built here in Denver, Lockheed Martin down in Littleton. And one of the sort of exciting things they've done, which we've done on previous missions, is to collect on the internet people's names and signatures and put them on microdots or microchips and send them along on the mission. And so here's one of these microchips holding 800,000 signatures. Here they're putting it on the deck of the InSight lander, and there's the 2 microchips. So 1.6 million signatures being sent to Mars. And so this spacecraft will launch in, well, the window opens, I believe it's May 4th or 5th, and it's got about a 6-week launch window. And it will land on Mars the Monday after Thanksgiving. So we don't have too long to wait for the next major mission to Mars. Sorry, what I wanted to show you here is just last week they did the test of the solar panels on board the spacecraft. Well, maybe. All right. Maybe not. Well, thankfully, oops. Okay. I think I just crashed my computer. Well, that's exciting. Okay, just a second. Don't send the complaint. All right, well, let's go to the still images. Maybe. Okay, so here's the solar panels unfolding. They're folded up sort of like Japanese fans, and then they slowly spiral out, and when they're completely deployed, they make this nice paddle-shaped solar panel, one on each side of the spacecraft, and that was a very successful test. So they're rapidly approaching the time that they will ship this spacecraft to the launch site, which in this case is going to be Vandenberg Air Force Base in California, and get it encapsulated in the payload fairing and get it ready to launch.